In this presentation, I'm going to go over research misconduct. Um, I am the chair of the Biomedical Institutional Review Board, and something we do each semester is we go through a series of presentation for faculty and students who are engaged in research, and we give them some best practices to help avoid certain things, in this case, research misconduct, and some other pieces of information to help them be effective in the research world. Now, what's odd is I have to give this presentation of research misconduct, and it seems like I'm going to be preaching how to not do misconduct. But I've been part of the Institutional Review Board for about 20 years, and there are very few faculty that are actually have done things that would be considered research misconduct. And even of those faculty that have done something that falls into this category, very few, a very, very, very small percentage of those faculty have done something purposefully. And what I will be talking about today is best practices to avoid research misconduct. I'll also define what research misconduct is and why we want to avoid it at the university level. So it's really an awkward presentation to give where it seems like I'm going to be preaching to people about not being, doing things wrong. And that's not what I do. What I do is I explain where research misconduct can accidentally happen. And again, very few people are doing it purposefully. And the way I like to start this discussion is actually talk about a different type of misconduct. And I'll talk about what happens in sports. So in particular, what happens in endurance sports. And believe it or not, people cheat in endurance events and sports in general. It's terrible, but they do. And even in endurance events like marathons or Ironman, iron distance events, which I enjoy participating and training for, people cheat. I don't understand why, but they do. Let me go through a couple of stories here. I've got the map here of the Ironman World Championship, which is in Kona, Hawaii. And there was a situation where an athlete, after the race, was sitting at the pool talking with some other athletes, and they were exchanging stories. And all of a sudden, an athlete's story just wasn't making sense. And what ended up coming out was the athlete would have had to have run almost a world record pace in the second half of the marathon portion of an iron distance event. Now, an iron distance event is 2.4 mile swim, 112-mile bike, and then a marathon, 26.2 mile run. And when they were sitting around the pool, they just started, figuring out that something was not right with this particular athlete's story. Well, lo and behold, someone posted something on a forum, and then all of a sudden it got out of hand, and a lot of people were starting to accuse this athlete of cheating. Well, let me tell you what happened, because this athlete actually came clean, got on the forum, and actually admitted to what had happened. This athlete did the swim, he did the bike, 112 miles, 2.4 mile swim, 112-mile bike, and he started the run, but he was feeling terrible. And he did this. This is the run portion of the Ironman. And you start in this area down here where this box is, and you run up Alley Drive, you run back, then you run out on the Queen K down into this, and what we call the Energy Lab, to this turnaround. And this is really a tough area because it's hot, it's dry, it's quite different than back in this region, which is hot and humid. Believe it or not, there's quite a very climate in this route. Well, what happened was this athlete was just not feeling good. And so somewhere around this region here, he decided to turn around, and he decided to DNF, what we call did not finish. Well, you're out in this area here. There's only one way back to the start, and that's to start going backwards, back on the course. And lo and behold, he starts to feeling a little bit better. Well, this part of the course is actually a little bbit downhill. And so you feel a little better going downhill instead of uphill. And he starts running, and all of a sudden he found himself down, here's this box down here, found himself in the last mile running down. People are cheering. He sees people he knows. He just is caught up in the moment, and he crosses the finish line. He didn't do this whole section of the course all the way out here. And that's why his splits just didn't make any sense. And in fact, there's different points of this course where your time gets recorded. You cross these timing mats, and it didn't match up. Well, he came on to the forum and actually explained and admitted that he turned around and told this story of just not feeling good, turned around, and all of a sudden he felt feeling better, and then he got caught up. He ended up contacting the race director and had the race director give him a DNF at that point. And that was a big step for this athlete. And I won't tell you his name, I don't actually remember it. But a lot of people actually gave him a lot of credit for saying, hey, you did a good job of actually doing the right thing and admitting that that you accidentally got caught up into the moment of finishing the Hawaii Ironman. And it's really kudos to him for admitting it. So that actually ended in a somewhat good story. He still got a DNF, but at least now he wasn't a cheater. Okay, so now so that was a story of where he cheated, but he wasn't planning to cheat. Well, this person here and this person here, these people were planning to cheat. All right. What do we got here? Well, this person down here, you see, he's doing a marathon. Well, this is a marathon, and these people are all completing a marathon. Well, this person doesn't look like he's completing a marathon, does he? He's not. He's in disguise. He's in camouflage. Here is a timing map. Once you cross over that timing map, your time is recorded. And what he's doing is he actually figured out where the timing mats were, and he would either bike or run, or excuse me, not bike or drive to the timing mats and cross the timing mat. And he would cross the timing mat at a particular time. So he was really planning this out, very much a scheme in order to get a fabulous run time. So he's cheating, and he's purposefully cheating. That's quite different than this story over here, where this athlete did some misconduct. But he admitted it, owned it, and got a DNF. But he didn't have any other negative aspects from that. And actually, a lot of people gave him a lot of credit for doing that. Same thing here with this athlete here. He's purposefully cheating. Well, I don't know if you can tell here. This is the swim portion of a triathlon. You can wear wetsuit, but you can't wear fins. He's carrying fins. So he ran into the water, put the fins on, and then swam with fins. You can't do that. That's cheating. In fact, this came out on an endurance forum, and he was on the endurance forum, and he said, "Oh, I found these fins when I was entering the water." You don't just find fins in the water like that. He was purposely carrying them in there, putting them on, and then swimming faster with the fins. So he's known as Fin Man. This guy doesn't have a nickname, but this guy down here, he actually went so far as he created fictitious races with fictitious athletes with fictitious times, and then he would have his own fictitious time in there, and he was trying to say, no, look, I have a history of doing these events and doing this well. It's all fabricated. It's all made up. It's pretty amazing that people will do this. So, in the endurance world, there's actually a watchdog of this, and this person actually started what is now known as marathon investigation. He was really focused on looking at people cheating in a marathon, but mostly he started with looking at who is cheating to get into a Boston marathon. And people cheat. They not only cut courses, but they give their bib or timing chip to a faster athlete and have that faster athlete run for them. We'll call that a mule. It's really pretty amazing that people will do that. And so this whole site, this person is now, their job is to investigate times and accusations of cheating, as well as trying to discover who may have cheated. And again, now we've got a couple different examples. People purposefully cheating and people cheating, but sort of falling into cheating. All right. So what I'm going to do, I haven't defined misconduct. I'm going to do that. I'll give you an overview of research misconduct, which is what I'm doing now. I'll give you the definition of research misconduct from a federal regulation perspective. And then I'll talk about research misconduct versus questionable research practices. And this is where we can sometimes get in trouble, but we need to really pay attention to what we're doing to avoid falling into that misconduct. Avoid that first example where the athlete turned around and then ultimately finished. He just shouldn't, he could have turned around, that's fine. Just don't cross the finish line and claim that you actually did the race. Now, what I also cover in this presentation is this concept that research is not always well defined. And I think of a research project sometimes as a bowl of jello. It shapes, it wiggles, it sort of changes its shape. Well, research can do that. And the trick is managing that bowl of jello. So it's still a bowl of jello and it doesn't get outside and it doesn't get messy. Research, how do we become good researchers? Well, it takes training. And you do an undergraduate degree, a bachelor's of science, a graduate degree, a master's of science, a PhD, maybe a DPT, EDD, and maybe you do a postdoc experience. You get additional training. This is years and years and years of training to be a good researcher. Good research is hard work. When I talk with industry partners about doing research, I always say it's easy to do bad research. So you got to be careful with who you hire to do research for you, who you contract to do research, because it's easy to do bad work. And this presentation is not geared to tell anyone how to conduct research. There's no one way to do it. There's all different ways to approach it, all different ways to be trained, as well as train students and researchers. What this presentation is about is geared towards talking about best practices. Science is predicated on trust. Why is this course important, and why are people required to take it? Well, it's because science is predicated on trust. Most researchers, and this is my position, and I firmly believe this, most researchers approach their work, their research, with the highest standards of ethics and integrity, for sure. A great deal of care goes into making sure that data are accurate, complete, and that safeguards and protections are strictly followed. That's the baseline. Now, if scientists are ethical and principled individuals, why do we need to do this research misconduct training? Well, part of it is to understand the process. All right, we've got to understand what rules are in place by the federal government to avoid putting subjects at risk, as well as avoid violating the concept of high standards for research. And this is a federal mandate. And the reason why we have rules like IRB and why we have 45 CFR 46, Common Federal Regulation, why we have these rules that we need to follow is because people have done misconduct. People have cheated. They've taken fins. So why? Why do you have a rule in the triathlon handbook? You can't use fins. Well, because someone used fins. Why do you have rules in a rule book? It's because often people cheat, or to help avoid people from cheating and making sure there's a level playing field for everyone. And public trust is at stake. And from a federal government perspective, there are cases of misconduct that are associated with federal funding, and that's taxpayer dollars, and we don't want to be financially irresponsible. Public trust is at stake. We want people to trust the science that is out there. Pursuit of scientific truth is damaged when we see incidences of misconduct. Public interest, health, and safety can be impacted if bad data are out there. It's a waste of taxpayers' money, like I said. The challenge, however, in the academic world is the reward system for promotion, where you get promoted through your academic ranks, or tenure, awarding of tenure, or merit, where you get additional pay based upon performance. That reward system is largely based on scholarship productivity. So there's pressure to publish, there's pressure to get grants, there's pressure to complete grant work as well. What's the extent of the problem? Well, 2% of scientists have reported committing misconduct at least once. And if you look at the number of people who are doing research that were polled, we're talking about up to 8,000 researchers are admitting that they've done some type of misconduct. So it's a real problem. 34% of scientists admitted to doing one or more questionable research practices. That could include something like an inappropriate analysis, overinterpretation of finding, or changing a study design for one reason or another in order to elicit some type of results. And these are published pieces of information. The point of putting this up here is it is a problem. People are doing misconduct. People are cheating in endurance events. We know it. It's a matter of trying to catch them, and it's a matter of telling and convincing people to not cheat in the first place. So what's the extent of the problem? Here's just more data. There are retractions when a paper is published and something is found out that there was something awry. A journal can actually retract that paper. Okay, while papers were published, it would be a little bit more of a lengthy process. But even in a digital world, it's a little quicker where you can unpublish a paper at that point. And here you can see these incidences of misconduct have increased over time. These are the number of incidences and the type of misconduct that was categorized. So this is going up to 2011. A lot more number of misconducts in this era versus in that era. Now, it might not have been documented as much, but it's also that the number of researchers are growing and the pressure to publish has increased over time. Here are some recent cases of misconduct, just like I talked about Thin Man and these other cheaters. Brian Dorian claimed he had replicated an experiment in 15 samples, but actually did it in fewer, and it influenced the statistical outcome. In essence, he was falsifying data in his PhD dissertation and many manuscripts. He was making data up. This researcher created fictitious data sets and published it. This one reported data from mice that never existed. And even, in the real world, German education minister resigns amidst plagiarism scandal, or 2013 headline. So these are people who actually were found to have been doing misconduct and cheated. It is a real problem. So now the next question is, what happens when there is research misconduct? Well, 24% of people who observed misconduct have reported to an institutional official. The institutional official is over in the provost office, and that's someone who oversees all research that happens on campus. So researchers may not feel compelled to report. Researchers are maybe worried about what happens if they do report misconduct. So just like in the real world in endurance events, well, what if you see someone cheating? Do you call them out? Do you not call them out? Are you worried what happens if you do call them out? Because it's not always well received. And some people can become very defensive and becomes very contentious when there's accusations of cheating with no real data. All right, well, what's interesting is, and this is sort of good news, is when someone has reported some research misconduct, there actually was not a negative fallout. And this is a good this is a graph of good information that that there really was not a negative instance when in the majority of cases when research misconduct was reported. All right, so now there is a problem. It's not a bad thing if you report something. Well, now let's get into what research misconduct is. And this is from the federal regulations in terms of what a definition of research misconduct is. Under the provisions of the federal research misconduct policy, research misconduct is defined as fabrication, falsification, or plagiarism in proposing, performing, or reviewing research or in reporting research results. And I emphasize these points down here with the bold and the underlining, because even though I mentioned the publication incidences, research misconduct can happen when you're proposing a study, when you're proposing a thesis project, when you're proposing a dissertation. So we've got to be aware that research misconduct can happen at any stage of the research process. All right, so now I'll go through each one of these. Fabrication is the making up of data or results or recording or reporting them. A supervisor accused a visiting postdoc research fellow of fabricating test scores on mice. This is just from different incidences that have happened. All right, so fabrication is making up data. Falsification is the manipulation of research materials, equipment, processes, or changing or omitting data or results such that the research is not accurately represented in the research record. So again, just an example here, falsely stating in the associated text that there were 10 mice per group and that the experiments were repeated once, while in fact there were only 5 mice per group with no repetition of this experiment. That sounds sort of minor, right? But that actually will influence the statistical outcome of a study where you make up data. You're just making it up. So it's falsification. Fabrication is manipulating data. So here's just an example of an image where you see 2 gentlemen here, this Stalin, and this is photoshopping, right? Yeah, this is photoshopping years and years and years ago. And there's a lot of photoshopping that can go on and a lot more sophisticated. This is actually pretty good where this person is just removed from the picture. Well, here's just some image processing where we don't need to know what this is, but this is an original image and this is the manipulated image, and using different filters and contrasting what you see here is different than what you see here. And if you don't report those steps that you use to yield this picture, that's falsification. Same thing here. Here's an original image. Here's a manipulated, and these are just other examples where this is the manipulated image and this is the original image. If you don't explain these steps to get to this image, it's falsification. In my world, we smooth data, we manipulate data as well, but we have to explain every step so that that procedure can be repeated by someone who's reading the manuscript. If you don't present those steps, then you are falsifying. Plagiarism is the appropriation of another person's ideas, processes, results, or words without giving appropriate credit. Cite all your sources, and use your own words to explain what is presented in a paper. If you use word for word the same thing that's in another paper that's published, you have to put it in quotes. And then you have to provide a citation. Unfortunately, there are instances of plagiarism, and sometimes it's unintentional. And sometimes the student or researcher just can't reword things. There's only so many ways you can say the sample rate was 1,000 hertz. 1,000 hertz was the sample. There's only so many ways. We just have to be careful about when we're trying to take someone else's ideas, processes, or results or words without really giving them credit. And so there are programs out there to look for plagiarism. And here's just some funny examples. Here's 2 cartoon images, which really is the same image, just different characters and maybe a little bit different background. Is that plagiarism? Well, what if it's your own work? Well, if it's copyrighted by someone else, it's actually plagiarism if you don't own that copyright. Here's just another image example. When Steve Jobs died, people were arguing which one was the original image because these are pretty similar. So which one came first, which one was published first, and did the other person plagiarize this idea of how to use that Apple image? Steve Jobs was Apple. Here's just another one. This is interesting. I got a friend who's does sculpture for his artwork. This is his artwork. This is somebody else's. He was at a ice sculpture contest, and he sees this person's ice sculpture, and he says, "Hey, that's my work." That person just plagiarized his sculpture. And so it was an interesting discussion that the 2 artists had in terms of replicating his work, pretty much straight on, and that's plagiarism. All right, so avoid plagiarism. Well, when we're writing things, especially when in doubt, cite your source. When paraphrasing, cite your source. When writing and you're taking material from a published paper, Cite your source. And paraphrasing, the whole idea there is you're putting another person's ideas in your own words. You're trying to focus content on a specific point, and it's a more detailed restatement versus a summary. Paraphrasing helps the writer better understand material. When you paraphrase what someone else wrote, you actually end up understanding the material better because you're understanding how to reword it in a way to understand. A lot of times what I tell students to do and what I do is I'll read something, I'll say, oh, I gotta include that in my paper. Then I read other things, and then I try to write down that point that I was getting from the original paper. And then I can go back and double check that I'm not taking word for word that person's idea. And then I cite my source. Continue to write, go back, revise, get a fresh perspective after reading other things. Uh, have other people read your work in the original work. And you do want to reduce the overuse of quotations. So sometimes someone's written something that's really good and you want to put it in quotations, that's fine, but you don't want a lot of word for word from another source. Use quotes to identify direct phrasing you have borrowed from a source. Cite your source. Cite, cite, cite. Always put your source in there when you've written something. And something that I often do when I'm reading a student's work or even another colleague's work is I do put in, hey, you got to cite the source here. This is just an example of paraphrasing. However, although humans are comparatively poor sprinters, they are also engaged in a different type of running, endurance running, defined as running many kilometers over extended periods of time using aerobic metabolism. Maybe this is a paraphrase. This may even still be too close. Having limited success in sprinting compared to other mammals, humans perform better in endurance running, which is a form of aerobic running over extended distances and periods of time. It's still putting the source in here. Plagiarism would be something like, although humans are relatively poor sprinters, they do engage in endurance running, defined as running many miles over extended periods of time. You can see there are just a select words that are changed or omitted. That gets too close to the original source, and this would, and no citation of the source here either. All right, so in addition to the federal regulation, UNLV also defines research misconduct as material failure to comply with applicable federal requirements for protection of researchers, human participants, or the public, or for ensuring welfare of laboratory animals. So there's just additional rules that UNLV has that you have to follow to avoid research misconduct. You also have to disclose all conflict of interest that you may have when you're doing a research study. And this is an emphasis on research misconduct is also an abuse of confidentiality. So if you get, confidentiality would be if you read a grant proposal. For example, even as students, you may end up on a committee where you're reviewing someone's work. When you're looking at that grant proposal, you can't say, oh, that's a great idea, I'm going to go do it. That's a loss of confidentiality. That's abuse of confidentiality. You can't do that. You gotta let that person who submitted the grant application own that idea. Okay, conflict of interest, I'm just defining it here a little bit more. Any outside activity or interest that may adversely affect, compromise, or be incompatible with the obligations of the employee at the institution. Using a position for personal financial gain. Well, here it comes back into play when we're working with an industry partner on a project. That's a conflict of interest because the industry partner may want to see certain results. And when I talk with industry partners, I've got to be really careful about not putting myself in a position where I'm producing results for them. And so I spend a lot of time with the industry partners talking about that and setting up a situation where I don't get stuck in a compromised position. But nevertheless, in a paper, if an industry partner provided funding or supplies, I have to put that in the paper and disclose that to the reader, so the reader can read that and say, oh yeah, well, so-and-so provided that. Well, of course they're going to say that's good. Well, and that's fine. Let the reader have that, understand that there may be a bias there. And even though you're trying to do the best you can to avoid that bias, the reader can read that and see that the conflict of interest was disclosed, and then decide how to handle that material at that time. Okay, I'm just continuing to talk about that. This confidentiality goes into when we're getting access to other papers through a review process, or anything where we sign a confidentiality agreement or an NDA, non-disclosure agreement, when we're working with a company. We don't want to give up where confidentiality is important and even implied. What research misconduct is not honest errors. It's not a difference of opinion, nor is it an issue when we're dealing with authorship. All right. Honest errors are honest errors. Okay. And you can own them, and you can still write about that when it's an honest mistake. A lot of times in our papers, or almost all the papers that we write a section that's specific to what we call confounding factors, or things that could have messed up our experiment that were unintentional. All right. So that's not research misconduct. Differences of opinion are not research. We may agree on one way to do it and another versus a different way, and that's fine. That's a dialogue. Research misconduct versus questionable research practices. Questionable research practices are sloppy, careless research, statistical errors, inappropriate allocation of authorship, that's sloppy, and even inaccurate references. So questionable research practices are far more common than actual research misconduct. And this is just some data talking about questionable research practices, and I'm not going to go through it in detail for this presentation, but I can tell you that the frequency of questionable research misconduct does change over time with rank of professor, because sometimes there is a little bit too much pressure for publishing and doing scholarship in order to move forward in rank. So research misconduct and consequent sloppy documentation, shortcuts, saving money, cutting corners, career advancement ahead of everything else. Consequences of research misconduct could be your career, could be your reputation, could be funding, could be your degree or license is revoked, or it could even be sanctions and even criminal charges. And there have been criminal charges against researchers. And here's just some examples. So this is the federal government Office of Research Integrity, and these are people who were found to have cheated in research. Just like Marathon Investigation, that actually publishes names of people who have been found to be cheated. And this is serious. These people now have sanctions against them for doing research misconduct. And if they change institutions, it has to be disclosed to that other institution that they've been found guilty of research misconduct. This is serious. All right, so quick summary: research misconduct from federal government, fabrication, falsification, plagiarism. From UNLV, it's a material failure to comply with the rules of the university. Conflict of interest, you've got to disclose them, and don't abuse confidentiality where it's either stated we need to maintain confidentiality, or it's implied. And it can happen at any stage of research, from proposing, performing, reviewing, reporting research. It's not honest mistakes. And so I always talk with students about making sure that we are honest and critical of ourselves when we're looking at our data and identifying any potential mistakes we made. And I've had instances where we have discovered mistakes when collecting data, and then we have to either start over, or we have to put those data aside and not use them. And that's fine. And that is part of the process, especially when we're learning to be researchers. And I expect mistakes to happen, but I also expect us to identify when we've made a mistake, as opposed to glossing over them. Questionable research practices, we want to avoid this. We want to avoid being sloppy, careless research. And what I do when I work with students on research projects, I get them to understand how to take good notes, how to create a binder of information that's specific to that study, and how to create a file structure on the computer or on Google Drive to maintain the data and then data integrity, as well as to keep notes and to keep confidentiality of those data. And this is our institutional official, Brad Woods. And I think that's it. Okay, I hope that's helpful. It sounds scary, but understanding the research misconduct process is the first step to not doing research misconduct. And just like I started, none of you would cheat in a run race. None of you. Well, I don't see any of you purposely conducting research misconduct, but we have to be careful about avoiding uh, unintentional research misconduct. Okay, I think that's it. Thanks, everyone.